Did you know you can use Integrated Architecture Builder, or IAB for short, to create a bill of material to help modernize your SLC system? In this video, we'll go through the process to migrate from a SLC to a CompactLogix. Keep in mind, the steps are the same for migrating from a PLC5 to a ControlLogix. If you don't have Integrated Architecture Builder, it's easy to locate. Simply run a Google search on Integrated Architecture Builder and select the entry that has Integrated Architecture Builder Tools and Resources. Once you've selected that, scroll down until you see Product Selection Toolbox and select the Download Now link. This will download the PST Lite install file. Please be patient as this download takes a while. Also, it's extremely helpful to have the SLC program open in RSLogix 500 while you use IAB to create the bill of material. This way, you can verify the chassis size and the part number for each I/O module. Typically, pictures of the existing chassis will help, but may not tell you the part number for each module. Let's get started by launching Integrated Architecture Builder. Click New Project. In the workspace name text box, type an appropriate name such as SLC Migration Wizard. Click SLC Migration in the Wizard view and click OK. In the SLC Migration Chassis Selection dialog box, click Add Chassis. Click OK in the Add Chassis dialog box to accept the default name for the new chassis, SLC 001, or you can rename it. With the SLC I/O field, you have multiple selections, with the main difference being replace the existing system or retain the existing system. With replace, the entire control system will be replaced by either the 1769 or the 5069 CompactLogix, or a ControlLogix system. With retain, the existing SLC chassis will be left in place and only the SLC controller is replaced with an Ethernet adapter module. That adapter module, along with the existing SLC I/O, will be controlled as a remote chassis with either the 1769 or 5069 CompactLogix. We will be replacing the SLC system with the 5069 CompactLogix system. As an added bonus, Integrated Architecture Builder will also provide the part numbers for the hardware conversion system. This means the whole control system can be migrated with little or no wiring changes. That's right, every single I/O module will be replaced, but the input and output wiring to the modules will not be touched. Under Chassis Size, select the existing SLC chassis. Under the Processor folder, select the existing processor part number. It's not a huge deal if you don't know the exact part number. Notice that the L306 and 310 can handle up to 8 I/O modules. If you have more than 8 modules, then select the L320. And if you have more than 16 modules, then select the L330. In this situation, we have 6 I/O modules, so I'm going to select the L310. You may get a notification about the SLC Communications Network. This is just letting you know that unless you had a SLC communicating on Ethernet, the old DH485 or DH Plus network will also need to be replaced by Ethernet. At this point, you can start dropping modules from the SLC project tree into the chassis at the top of the screen. Select I/O module, then digital, and then the SLC module that you'll put in slot 0. Reference the I/O configuration folder in RSLogix 500 to verify the module part number. In this case, we'll be selecting an IA16 in slot 1 and slot 2. Drag an OW16 up to slot 3. Depending on the module, you'll get an informational message once the module is dropped into place. Select OK. Now drop another OW16 into slot 4. Scroll back up to the top of the tree and select the analog folder. Drag the NI8 up to slot 5 and select OK to the informational message. By the way, all 5069 IF8s manufactured after June of 2023 allow for single-ended device wiring. Drag an NO4V up to slot 6. We have finished populating the SLC chassis with I/O modules based on the existing system. Now select OK at the lower left. SLCs were capable of controlling multiple chassis using a chassis interconnect cable. If you had multiple chassis, you'd add the second and third chassis here. We'll select Generate Hardware. The migration window closes and you're probably wondering what to do next. Select the Hardware tab on the lower left tab listing. It's the center tab, and this will bring up a graphic of the replacement system. Expand the slick_migration folder. Now expand the 5069 chassis folder. You will see the replacement components listed there. You may notice that a 5069 FPD was added to the layout. The FPD, or Field Potential Distributor, simply stops the sensor actuator bus power. No issue wiring 120 volts AC to the sensor actuator bus terminal on an L320ER controller. But the I/O modules to the right of an FPD require 24 volt DC sensor actuator power. And inserting an FPD is how we make that happen. Wire 24 volts DC to the FPD, and now all the modules to the right are happy. Warning: 120 volt AC cannot be wired to the sensor actuator terminal on a SEAL 2 or SEAL 3 CompactLogix Guard controller. Select the File pull-down menu and select Project Bill of Material. Select OK. If you get the Please Note window, it's a good idea to research the errors or warnings by visiting the Project Checker. For this system, we'll press on by select Continue Generation of Bill of Material. Select Yes to save changes. At this point, a Bill of Material window will appear. There are 3 ways to view the Bill of Material, but we'll leave the default and then select Save to XLS. Either leave the default name of the file or rename it. If you want to see the BOM, now select Yes. As we said earlier, we're adding the hardware conversion system to reduce our wiring time to just a few minutes to do a full chassis upgrade. If you don't want to use the conversion system, then delete all the 1492 components from the system. You'll need to add back an I/O module terminal block for each of the I/O modules. This part number will either be a 5069 RTB18-screw, or it's going to be a 5069-RTB18-spring. Thank you for watching, and if you need further assistance, please contact your local ES&E account manager or automation specialist.